All right, so this is Chem 30, and we are looking at ice charts. And this is question number 3 from possibly a handout assignment that you've gotten from me. But it says this: in the reaction 2HCl is in equilibrium with H2 and Cl2. Here's the KEQ, which is a number that's going to be pretty important a little bit later. But with these ice charts, what happens is we are looking for we're either looking for concentrations at equilibrium, and some points, and sometimes we're talking about what are the concentrations required at the beginning. And so if we look at this one, number 3, it says how many moles of HCl are needed, you see, are needed initially in a 1 liter flask to produce 0.6 moles of Cl2. So we're going to use our ice chart, but instead of having, let's say, X down at the bottom, in the bottom row, we're going to need to find out, if we can find out what X is, we're going to put it in the top. So let's see. We go like this, ICE, right? And this is the initial. And then the second row is the change. And then E is equilibrium. And of course, I'm going to put HCl there, I'm going to put H2 here, and I'm going to put Cl2 over here. So we're going to have basically 3 columns, right? All right, so it says how many moles of HCl are needed? So my unknown is going to be up here somewhere. So how do I build the unknown part up here? Well, 0.6 moles of Cl2 is at equilibrium. So this is 0.6, we know that. And because this is a 1-to-1 ratio, I'm also going to have 0.6 here. We can also assume that we're starting with only HCl, I guess. So this is going to be 0 at the beginning for H2 and Cl. Okay? So what's happened here? Well, we've changed from 0 to 0.6, and so the change is positive 0.6. Okay, because we go from 0 and we're at 0.6 at equilibrium. Now, HCl, okay, we don't know what we have to begin with, we don't know what we have at equilibrium, but we know what this change is. We know this change is minus, well, actually, what is it? This is a 2-to-1 ratio. So if this is adding 0.6, this has to be a 2-to-1, and I think sometimes we might want to do this just to remind ourselves. So if this is 1, what is 2? Well, it would be double 0.6. And of course, we're starting with some HCl and we're going to go down at equilibrium because this is going to shift this way until we have enough of this and enough of this, and then it's going to bounce back, right? So there's going to be a little bit of this, and it's going to be a little bit of everything. And at equilibrium, which of course we're going to do all of our calculations with the equilibrium row, right? That's what's important. So we're going to go, equilibrium is going to be some unknown value, but we know that it has gone down by 1.2 moles. So this is our unknown in number 3. And this is how we set up our equilibrium row. So we know that KEQ, right, is built from the products of the the products of the products, I guess, the multiplication of the products. So we're going to go H2 times Cl2, and they're both to the power of 1, so that's great. Okay, and then HCl, well, under here, right, we have X minus 1.2 for a concentration, and there's a 2 there, so I think that means we have to square that. Does that look right? Okay, are we with me so far? Hope so. So the KEQ here is 2, what is that, to the negative 2, correct? Yeah. So 2.00 times 10 to the negative 2 here. And that's going to equal, what's H2 and Cl2 at equilibrium? Well, they're 0.6 and 0.6. So up here is going to be 0.6 times 0.6. And then down here, we have X minus 1.2 squared. So we're gonna have to multiply here. It looks like we're gonna have a quadratic situation, right? So I tell you what, let's maybe do this. Let's maybe expand this bottom one first. So maybe I won't erase that. Maybe I'll just rewrite that. So 2. Yes, yes, actually you could do that as well. So that's a good point. The question was, can you just take the square root of both sides, being that this is, we have a 0.6 squared up here, and yeah, and we have, yeah, so let me just rewrite that like this. Yeah, that'd be the best way to do that actually. We could take now the square root of both sides of the equation because these are perfect squares up here, so that's a great idea. All right, so 2.00 and then times 10, so we're going to use our exponent button to the -2. And, oops, I want to take the square root of that, don't I? The square root of that number is 0.1414, and so on. And over here, yeah, we just have 0.6 back when we take the square root of that. And down here, we just have x minus 1.2. So, yeah. That would be great. You could expand this out and multiply and use the quadratic that way, but you could also take the square root of both sides as well. So now we do have to multiply here, up across there like that, across the equal sign, and so I get 0.1414x minus, and I'm going to take this number and multiply by 1.2, and so that's going to be about 0.1697. 0.1697 equals 0.6. So this is great. We just have x in one spot, so we don't need to use the quadratic formula because we took the square root there before, so that's great. This is 0.1414 equals, and now what's, I guess we're going to do 0.6 plus this number. So this 0.6 plus 0.169 is 0.7697. And then we, oops, I forgot the x there. And then we'll divide by 1414, both sides. 0.1414 that is. And so let's do that, divided by 0.1414. And I'm going to use some more decimals to make sure we're a little more accurate here. 3,562. And so we've got 5.44. Okay, and you know what? That's what x equals according to our math, and that's exactly what we're looking for in this question. We're looking for x, and so the units would be moles. And I guess I should say that one thing I did forget to mention really. This is in a 1 liter flask, so 0.6 moles in 1 liter. That is 0.6 molar. I forgot to mention that, but because this is in a 1 liter flask, this does need to be in concentration, right? So if this was other than 1 liter, then we would have to do the calculation this divided by this. But 0.6 moles divided by 1 liter is 0.6 moles per liter. So we do have to have concentration values there. So that makes this 5.44 moles per liter of HCl. So I think that should be your answer for question number 3 in your assignment there. Moles per liter of HCl, that's what's initially going to be required. So I guess just a couple notes. We can assume how many moles of HCl are needed to produce this according to this equation. You can assume that there's 0 of H2 and Cl2. And when it does give you just one concentration of a product, and there is another product that behaves in the exact same way because there's 1 and 1 ratio, then they're both going to behave in the same way. You can fill out 2 spots there, even if you're just given information for 1. So okay, so that's ice chart assignment number 3.